Session. Okay, welcome everyone to our education session for Tuesday, July 28th. Tomislav, you're ready to go.
Hello. So for today, we are continuing our Simple Rholang and this relationship between defining operations and modifying some internal state. So I will share my screen, and I didn't prepare everything in front, so I will be writing code directly. So if you have any question, please let me know. We can do it together, and I will probably have some many errors. It would be more fun if you are joining with questions and comments. So let me first recap what we have. So we have our concurrent language, which is Simple Rholang, and our language is really based on these four operations. So we have nil as a stop process, which means basically do nothing. We have a par, which connects two processes to run in parallel. We have send, so we can send any process, and we can receive any process. Meaning of the send and receive is not the same in the real Rholang, but here we just want to have something very simple. So we don't have any additional arguments to what we are sending. We just have this name or channel to send something. And for today's session, we want to extend this send to also have some value that we are sending on this name or channel. So basically, what we're going to do today is send some value here, and this value can be any type that we want, but we already have our process, so why not send the process itself? So defining our operation is basically our basic rules for our language. These are the words from which we can construct our sentences in our language. So the meaning of this way of thinking is our operation manipulates some internal state. So with these four operations, we are manipulating this internal state defined with these classes. They are all extending the process itself, and this is what from outside what we see, because all of the other classes they are private. And I will explain what we have from our state. So the whole state is really inside this par class, and this is for now we have this as a set of the process itself. The other two classes are basically just to hold the information that we are sending with our send and receive operation. So now, we were talking about how our semantics of our language works, and this is really like operational semantics of our language. So now I can also show that we can construct some bigger terms from these basic constructs that we have, and the constructing term in our language is the par, and the par I mentioned operation par. Sorry for moving up and down. Operation of par. I said we can connect two processes and run it in parallel. So this is basically the binary function accepts two processes and return a process. I also mentioned this is maybe Daniel, this is familiar to this nil and par are constructs that are forming a monoid operations. We have this process as the structure, and we have empty and combine as the monoid operations. And this is the nil and par. This is the empty process and the binary operation. So with this par, we can combine any other constructs that we have to run it in parallel. And this is how we are writing our programs. So and now I will not go into detail how our evaluator works and how we are what meaning do we assign to execution of our language, because we can have different meaning, and from the perspective of defining the language inside some other language, we can have different implementations. So this is how usually we think about describing some abstractions. This is like our mini domain specific language, and implementation can be something useful that we want to execute, but also it can be mocking for writing tests, so we can check our logic. Is it okay or not? So does this make sense? Is there any questions? Okay. So now I would like to move to basically implement what I said, and also what Dean Worm suggested in Discord. So we want to add additional argument to our send operation, and we automatically need to think about, we need to store it in some way in our state. So what I'm basically what I'm doing is I'm extending operation send with additional argument, and I want to do the same thing in our state, because I want to store this additional value for the use in evaluator. So I will do the same thing here. So now we have additional argument. The whole class is also a process, so it will be stored inside this set. But what we are doing in evaluator, now we will have a problem, because our logic in our language is when you are sending something on some channel, and where you're when we have someone who is receiving, we will just delete the sender receives. So this is like erasing, or we have some point of communication, but because we don't have any additional arguments, we are just deleting the sender receives. So they are like canceling each other. So now, and this is we can do this because we are searching for this class, for this instance of this class inside the state, which is the set. And so this means that if we have send on some name and receive, and we can match the receive on the same name. So basically we are searching the same structure inside set, the same element we are searching. So now when we have additional argument here, this is not really the case, because in this situation this will work, because we still have receive with only the name. But in other way around, if we are searching for a send, and when we have the receive, this will not work, because we don't know what to put here as the value. because in the set, different value gives us different value will give will be a different element in the set. So we need to extract only the name and say, you know, I'm searching for this unique name, and whatever you have in the as the value is not important for matching. So this means that our state as a set is not enough. We need to extend this structure, and maybe someone has some idea how can we store the names that are unique and also the value related to this name. So structure that is very similar to set, but it's also extending with additional data is the map or associative array, as I learned the last time from Jim. So basically what I'm saying is we want to have something like a map that will store our process. This will be the name or the channel, and also the value that is associated with this name or this channel. And now we basically are changing our state, and we need to refactor all of the places where we are using our state. So in the real program, this will be probably like a huge deal to do. So let's see. So we are creating our empty map. So now our par operation, which has a meaning of combining processes that we are receiving, that we want to run in parallel, we want to somehow merge and hold all of these processes inside our state. And previously, the set was giving us some useful properties. For example, if we are combining some process with empty process, this will result in the process itself, because empty process will running in parallel with some other process P doesn't change anything about P, and we have this property on both sides. So empty on the left and the right. We call this property in the monoid monoid structure left and right unit, because unit doesn't change the operation of doesn't change the process that is combined with. Another case that we are also guarding is if we already have processes that are combined in our monoid, and we are combining this with something else, we want to extract or flatten out our set. So we want to take out set that we have inside par class, our state, and we want to combine with whatever we have on the another side. And this is our plus operation here for set. So now we don't have this plus operation on a map, because now here we have a map of process, and here we have another process. So so we know that whatever we have here, what we need to do. Basically, we need what we want is for our send, we want to extract, because now send becomes something that is that we cannot just store in the same way. So let's see. I was thinking that this would be something that it would be interesting to do directly on the session, but I'm not sure that that would be interesting to develop directly, because sorry.
Wouldn't this just be a tuple? You would have a tuple of the name and the process.
Yeah. Now I'm thinking that I need to detect that this is sent inside existing par, and this complicates things because we need to iterate over the whole set, which will be much more complicated to write here, and I don't want to don't want to have something very complicated here for this example. So I didn't think through about all of these things. Maybe we can skip this step and see on the other places how can we done something simpler in the session, and I will figure out how to do this this whole example. Basically, what we want to do with our we need to match that what we already have, because now we need to extract the name from the send. Yeah, this is. I was thinking that this would be like more straightforward, but it's not. Are you following me so far, or?
Yes.
I also have another thing that I want to show, very related to that, but in the JavaScript world. So maybe I want to jump there because I'm not really ready to what I was thinking here. Sorry about that. This is in ClientJS library, and I wanted to, when I build this example, I really have this in mind. The same style of having a state that we are modifying. So first of all, I will say that we have this control files. And so let me start first. This is a web application that is basically doing this thing here. So we have some drop downs that are cascading. So when we are changing in one drop down, we want to update the next drop down. And this is something that is usually when you want to do this in UI, it's complicates things a lot, because you need to you need to have the state and follow the state in one dropdown and another dropdown when one triggered another, and so it's complicated things. And so I want to show how this can be done more easily, especially if we have something like the virtual DOM. That are giving us some additional layer between our JavaScript code and a browser DOM. So basically the whole application is in these files. And I will show, I can show any of these controls and they're functioning in the same way. So for example, this selector with, okay, let's start with something more simple, like checking the ref balance. So basically this, each of these sections separated with lines is one control. So I can say, I can first show the balance, which is only a dropdown and one button. And this is the balance control here. The HTML is here, which defines the label, some text, some label, the drop down, and the button here. And we also have some messages that we are showing beneath the button. What is important here is here we can think about this HTML basically the same as React or virtual DOM created with React. JS6 written in JS6 style that looks like HTML, or directly in JavaScript, what I'm using here. So this M here really represents this one library for creating virtual DOM. Why we want to do this? Because in this style of or defining UI, our HTML definition is really the render function. It represents the state of UI. It represents whatever input object, JavaScript, plain JavaScript object that we have, that we are from which we are creating this representation of virtual DOM, is directly correlated to our representation in UI. So we are thinking in this way that we are executing this function on every change. On every change on our UI, we are running this function, and we are creating another representation of UI. This is a different from you know, few years ago that we were developing applications and directly changing the state in UI and thinking about the binding and what will happen on some click on the button and this kind of way. Our state is separated from UI. So now we are thinking about whenever state is changing, we are executing our render, we are creating a new HTML, and this HTML will be shown in the browser. This virtual DOM is the layer that is taking care of the changes, directly of the changes. So we can change our object how much we want, but only only changes that are only change in the UI that are created from the previous version of UI will be applied to the DOM. So so we don't need to take care of this part of like caching or is it this very slow because we are creating new HTML on each change. So this is the job of virtual DOM. I'm not I don't know how much you are familiar with React and the virtual DOM. So I hope this this helps for this level of presentation. So now I want to focus on this relationship between the state and the operation that I shown in Scala with our simple Rholang. One thing. So let's see what is our state. So I showed that here is the basically creating HTML, which this virtual HTML. But so and our input to our control is basically JavaScript objects. But there so one concept that I want to explain is this state is not just the clear object with properties directly like a plain object. It's the wrapper around the state, and it can be seen basically as the cell or the reference to the state that is inside. But this state can be accessed or this state object has some basic operations that we can execute to get to the state inside or to change the state. And this is very crucial for all of this implementation, because every time we are changing this state from the UI, when we say, oh, now I have like a click on the button, I need to change the state. Each change of the state will render the whole UI. And that's basically the whole concept of how we can build UI with the virtual DOM and our state. And this is very, very similar how, for example, Redux, how Redux works. We are defining these actions, and we are defining reducers, and applying some action will execute some our reducers that we have with Redux. And here, this is more direct. So we don't have some additional stuff that we are defining these actions as the string. We can directly operate on the state. We can for example say like here we are directly using our set and get operations, or to be more concrete, correct, view and the set. These are our basic operations. I will show you how this looks like, this state wrapper, because without that you cannot know what is going on with in the background of calling view or calling set. But just from the perspective of looking at the control for this UI, we can see that our control is completely defined by input arguments to generate the HTML result, this virtual DOM result. And this is what we want, right? We want to have pure functions which operates in our application. So our control is completely pure. We can very easily mock our input arguments and check what result do we have, what HTML do we want. So this is like the basic concept, that we can just iterate and build more complicated controls, but we are still developing always in the one pattern without changing anything special. I will not go too much in detail what we have defined here, but basically I defined some events that we are caring about for this control. And this is when we are changing the select, when we are changing the dropdown, and we are pressing the button. So we have on click on the button event, and we have on change on the dropdown on the select. And this is the two functions that I defined here. So it's very easy to think in this way. We have the state, we have our control that operates on this state, that is using some information from the state, and we have our render result, which is HTML. And how we are writing our code is not important, right? We can use different styles. This is not important. We can use React here with JS6 syntax, whatever. It's completely irrelevant what we are using, or maybe other language, right? The same style with the Simple Rholang here is the style is very similar. We have our state, and we have our operations on the state, which are like protecting our state. So let me now go briefly to what is this state? And this is in a common file. And our state is this. it's not super important that we go into every detail, but it's important that we see these operations that we have. So we have view, set, update, and this O. The O is from composition, like a dot in mathematics to compose functions, because this is exactly what we are doing. We are composing functions. The basic concept is our state is a plain object, a plain JavaScript object. So I can write here. So for example, if we have object with one property, for example, my prop, and we have another property that is nested, and we have another object inside. So let's this object bit B, and this can be nested value, right? What I'm missing?
Yes. The B object was wrong. It has no key.
Yeah, exactly. Right, thanks. So you can imagine that this A object can be our state in our application. And we have this view and set as functions to get some value inside our object and to set some object inside. And here I'm using one library for creating this so-called lenses. And what are the lenses? So this view and set accepting so that not view directly, but creating this substructure is accepting the path. And what is the path? Path in our object can be this my prop, for example. If I say dot my prop, I'm really saying I have this path from starting of the object. I have this path my prop to get this value, or even I can have different path to get to this nested object. So I need to specify two levels to get to this object. And this representation or this specification of our properties is really the path here. So we are specifying how to get inside of our object. And this is very simple implementation, what we can do with lenses. We can do much more, and we can have much more complicated lenses. But this library is giving us like very, very basic thing. But it's completely enough that we can use it. One important thing that is very crucial for this application to work, or this way, this implementation, is that we can combine multiple paths. So you can imagine that with our lenses, we can have lens defined in this way. And better, this can be an array where we are saying, first, you need to go to the nested. The first level is to get the nested object from the root object, and then go one level deeper and go to the B. I don't have lens function here in the console, but this is basically what we are doing here. We are creating this lens object from the path that we are supplying. And where we are using this path, I will go back to the main control. So our it's on the top. Our whole application is also the same as control. That's the important thing. We want to combine smaller pieces that are working, that we know how it works, and we have some pattern that is useful for us. And we want to combine multiple controls and just do the same thing. We don't want to have application created in different way than one control. So our whole application, our main control, is basically the same as any other control. There is no difference. We are accepting the state, this special wrapper around state, in the same way how we are doing this on any other control, balance or more complicated control. So our main control is really composition of some smaller controls. And what this means for the state, we are composing the state also. So with this compose operation, we are saying, take the state what you have for the whole application, and go a little deep and select this cell property, cell field, and also do this for address, and do this for balance, and do this for transfer and custom deploy. So you can also you can now imagine how our main state looks like. It's basically it must be something like so our app state must be something that have cell inside with something, and it has something with address, and it must have something with balance. And these other properties. And here we are just selecting and saying, yeah, we want our wrapper only around this address field. And what this is giving to us is state created. This composition means grab the object inside, but not directly, not that we have a reference to the object. We have the same cell that are holding our whole state of the whole application. Now we have this lens. We are lensing inside this giant object for the whole application. We are lensing and taking only the one part for the one property. And when we have this, we can supply this restricted object. So now our address state doesn't see what is in application state. So this is also very much related to object capabilities, because we are restricting our scope. We are saying now you can only see what is inside the field address. You don't have access to all the other properties that are on the same level. And with this restricted state, only inside our global state, we are supplying this object to our address control here. And this is our first argument. If I go to address control, this means this state, this first argument, is our wrapper around state field of the global state of application. And now we can operate in the same way on our address state. We can select something inside the address even more in detail. So we can go even deeper in our control and developing even smaller and smaller detail of our application. but our complete logic is always the same. We are not changing the abstraction or different way of developing application. We always have the wrapper around the state in whatever form we have. So this is like restricted to others. So whatever our parent is giving to us, we can use it. And this is also from the perspective of developing applications. Maybe this control will be developed with completely different team, right? And you don't want to give these developers access to the whole application state. You will say, you know, you will have only this wrapper around this address. So you are developing this address control, and this is exactly what is available to you. This doesn't mean that some read-only stuff we cannot supply, because with this state, this is our little language, right? Our mini language for operating on state. We can get view and get, but we can also supply additional arguments to say, yeah, but here is some information that you can only read, and you cannot change this information. I'm a little lying here because theoretically, if this is an array in JavaScript, you can you can change this array, and you know, but you are cheating, right? What we want to say with this, like semantics, this is like a read only. You don't have a wrapper around this state. This is plain JavaScript objects, and it is meant to be read, just to be read. So the wallet is something that is not inside others, but it's useful for our others control to have access to read from the whole wallet, because we are showing our wallet with all the addresses here. So this can be something new, and we are showing this in our list here. So even if our control does not manipulate the wallet directly, it can read it can receive this additional information like wallet list to show on the UI, because this is like a usual thing in UI. You know, you're manipulating only a very small part of the state, but you are showing some bigger view in your control. And I mean, the address control is basically the same, but a little more complicated, because it's doing more things. But it's the logic is the same. The HTML is generated here for this virtual DOM. If this makes sense, how we are supplying this wrapper around state, and this is our small language for UI. Do you maybe have some question about that, or you know, what I'm missing, or?
I think it's cool.
Thanks. I know that is a sorry.
Explanation for me as well. I'm still learning a lot about this, but I learned a lot about the JavaScript listening to this discussion.
I was trying to dig into Lens a little bit further. Do you have any references for that? Is that I only found something in Haskell repo.
Yes, I mean, in Haskell, all of these lenses can be really typed and checked by compiler, and in JavaScript, or for example TypeScript, is not type system in TypeScript is not like rich enough to express these lenses. What I'm using in JavaScript is Lambda.js, and when you select lens, you will see the basic concepts.
Right. Thank you. Yeah, I was digging around for where you got it, and I'm very new to this as well. Thank you.
I'm using this library, and but this library this is functional library for JavaScript, and it's very nice, and you know, I'm using this like in every JS project. But I have much better example. It's partial lenses. This is very rich library. Where is the link? With no, I'm searching for interactive site. It needs some time on the to start on the first run, and here there is a lot of lenses we can choose. So not only that we can do set and get. I mean, basically we have set and get. This is the basic operations for lenses, but only for this, only with these basic operations. Like this is our lens language. Only with these basic operations we can build all of these other very complicated lenses. And there is lots of lenses. And for example, yeah, there is also a notion of prism, and prism is the lens where on the other side maybe you don't have the data. So maybe you will I mean, maybe you are lensing to something that is not set, or maybe in the array there is no element on this index. And this is supported by the lenses. What I just want to show on this example is we can on this site we can change something, and this is automatically refreshed here. So it's completely interactive. So it's very nice. Yeah, that's it. I'm not sure that I want something else to show.
That's cool. That's cool. That helps me follow what you're doing in your client. I had trouble following. I was actually running to Will Q's Python, which is kind of more readable without understanding some of this.
Cool. Yeah, basically, I'm not saying which library do we want to use. I mean, we can define our lenses ourselves, just get and set. This is not very complicated. But if we want to use more complicated stuff, then it becomes much more usable. For example, one function that if you developed an UI, you will have this situation. We have array, and we need to update. So we have some like a list of something, and in this case, a list of accounts. So we have something, right? So some list. When we adding something new, for example, new account, we can add some new name, right? And this will be added to the end of the list. For example, we want this logic. But when we change something, and we update existing record in the list, we want to detect this and not add to the end of the list, right? Like here. And this logic, you know, it's very basic, and it sounds very simple. But when you start writing the code, it becomes more complicated because you need to iterate over the list, find if you have if this is already in the list, and update in this position. If you don't have, you will definitely go to over the whole list, so that you find out that you don't have it, and now you need to append to the last element or the first. And with lenses, this basic stuff can be defined in function like this. We can just say, oh, give me the index of the list if it exists. If not, use this lens to append, or use this lens to the specify index if it exists to set the element in that position. So basically, we are saying, oh, if this element doesn't exist in the list, we will create a lens to the last element. So when we use this lens to set or get, we will get or set this last element. And if we are using the update on the specified index, we are lensing not to the last element that doesn't exist, but to existing element, so that operation get on set will give us element on this index, or we are setting element on this index. So this function to update the existing list becomes very, very simple, right? We don't need to do this manual traversing or checking, or we are just detecting, is this element in the list? If not, we are just deciding which lens do we want to use, and that's it. So this kind of thing becomes much more easy to express. And how can we use this lens? In the same way how we are accessing our field to specify from some global object, like here we are composing our state that we have. So we are saying dot wallet, and then we are using our append update lens to say if this object inside this wallet list is equal. So now I'm using also this shortcut, this helper function from Lambda to select a property. So just not to be confused, this represents this stuff. So this is this function is equal to this function, prop.it. So this whole expression is equal to this. So this function is equal to this function. So this is just a different way of defining. But basically, this is a predicate function for this lens. We are saying, we are detecting if this will be called here. We are detecting if we have this index, so that this rev address is the same address that we have. This is a unique component of our wallet. And after that, so this is the selection. And after that, we are setting this account to the new value. And this is how we are composing our lenses. We are going inside our object, and then we are also going inside our list. Not just the object, but also the index in the list. But in the same way, how we are accessing our object, we can also access some kind of list with some index, right? In the same way. From the perspective of lenses, we are just going deeper in our object, right? The same logic is here. I hope this clarifies a little what I want to show. And the whole object is here. Where is it? There is our initial state. And our initial state is supplied here as the first, like a big bang, right? the first initial push to our application to start. And basically, this is also the same concept. We are supplying to our render function, our main control, we are supplying our first state, our first wrapper to the state. In the same way how the main control will supply to our child controls, the whole application is also control that we will just call with our initial state. And that's it. So it's a very small logic or this pattern that we need to have in our head, right? We are just supplying the state, and we have this render, and we only need to think about what part of the state we are supplying in some specific control, and that's it.
Concise and elegant.
Yeah, it must be simple, right? If if our basic concept to create application is complicated, then everything else will be complicated, right? Because we need to repeat this process many times for each control, you know, and this iteration must be very simple. Must be, you know, must have a small amount of components. So we can just manipulate the state and render the state. So basically, we're only thing that we need to keep in mind: what is the shape of our state, and what is the render function that we want to show to in UI. And that's the only thing that we need to take care. And here, there is no any sign of, okay, there is, I put these functions here related to Rholang, but basically there is no direct connection to operating on Rholang. All the interface is inside this rnode web file. So we have RChain network to show what network do we have here in this dropdown. This is in one file, and we have our web interface to rnode in this file. And this is also separated here. The controls are in a separate folder, and in the root, we have these two files for communicating with rnode. So this is also something that we want to do in when we are building application. We want to separate different concerns. So we can totally separate our web logic, which is defined by our structure, and we can have, you know, connection to whatever we want, right? Not directly related to our components. Okay.
I have to go, but that was cool.
Yep. Thanks for joining.
Thanks.
Yeah, we are 3 minutes over the hour. So
Hey, Jacob.
Yeah.
Bye, guys.
Bye. If you have some comment or whatever you have in mind, please.
I think you've got all the pieces here for people to use to build off of. That's a really nice framework. Just to got the foundation. Yeah,
I want to show. I don't want to say that this is the only way, right? But it is nice that we can recognize the concepts in other frameworks that are really doing this thing, right? We can use Redux or some other framework, but at the end, or for example, React hooks. But basically, you know, at the end, this is what we are doing, but with a little more, some boilerplate code or you know, some helper functions that they create, and you know, but basically, you know, at the end, this is what we are doing. You know, we have some smaller language with some state that we are interacting. Okay. Do you have some idea for the next time? Do you want that? So yeah. What I wanted to announce is Nadzipper, Will, and I are thinking to join the language jam, programming language jam from a repl.it site, and I'm wondering if and here is the link. I want to ask if anyone want to join or have some idea, because now first we need to see can we, yeah, so first of all, this is like a competition for building some, you know, crazy new language and they will add this to their site as the supporting language. So first we need to see if we can use our existing Rholang as this new language, or we need to build it from scratch. What I was thinking, it would be nice to have Rholang directly in JavaScript. So I'm not saying this is like an easy task to write the whole Rholang in JavaScript. I was thinking more, to write some like a simple version, but also if we can use existing version of Rholang for this purpose, that will be much easier. So for now, we are just thinking about that. So if you have any opinion or if you want to join, please let us know.
What about
Tomislav, I was looking at the repl.it site, and I'm curious, what do you use it for? How did you come to know about repl.it?
Oh, I'm using it for showing the some code and to run the code and like examples and this kind of thing. For example,
So
one thing was.
Do you make much use of the editor that they have in their web app?
Oh yeah, I like the editor. It's working very well. Let me show you. For example, I have REPL for Arnold gRPC. So the project that I was showing you is one example, but for example, to use gRPC, we cannot use gRPC in the browser. And what repl.it site gives us, we can run Node.js directly. I mean, it's not in the browser, but we are communicating with the server. But we can run it, right? We can write, we can have this in the browser, and we can, run it on their servers, and we can execute this code. So basically, we don't need to install Node.js or some other language on our local machine, and we can execute the code. So here I'm directly taking this from the mainnet. I'm creating requests to the mainnet, and this is the whole code. So I'm loading the real packages. I'm generating the JavaScript client JavaScript code for gRPC. This is in the same, completely the same as I have it on my machine.
The site repl.it claims that they're sort of like a glitch, but glitch only allows you to write programs in JavaScript. So they're much broader than that. They let you write programs in any language that they support. And
yes.
we're hoping to add Rholang to that list of languages.
Yes, exactly.
So I'm assuming that you're saying, can we use what we currently have, which you mean the Scala implementation of Rholang? Yeah,
exactly.
And so we would, I guess you're saying we could try to get it running over there now, and if it works, then we would ask the repl.it people if they would add it to their list of supported languages?
Yeah, they're saying whoever wins on these contest, their language will be added to the supported language.
Okay, it's not just a matter of if it works, we've also got to win this contest.
Yes.
But if it works, it still would be something, right?
Yeah. I mean, basically, we have something already right now, our RChain cloud. But we will need some modifications because in repl.it each user has separation, right? When you execute some code, you're not messing with the state of our other executions. So from that perspective, I was thinking that some simpler version of Rholang would be more lightweight, right? But yeah, it's doable. It's doable what we have now.
What about Roxy?
Yeah, something like that. Exactly. Yeah, we can definitely, you know, maybe take part of it, or yeah, this is a like good idea. Yeah. And I'm also thinking, you know, we can write this in Scala and use Scala.js to have directly in the browser. I mean, we cannot use existing code. It's like too huge for Scala.js, but you know, maybe writing in Scala. So I'm not sure, you know. This is just one of idea, yeah. Rafael, you wanted to say something, yeah.
Yes, about you know, Rholang interpreted in JavaScript. It's interesting even for the DAPI project because of third-party application issuing transactions. If we have this, basically we in the DAPI browser without checking any other service, we would be able to say that this transaction is a true valid sending ref transaction, and this one is kind of an unknown transaction. And we would have a way to kind of label transactions that are safe or that do exactly one precise thing. Because right now we can't do it in DAPI. We can just say that some third-party application issues a transaction, but we cannot tell anything about what this transaction does.
Yeah, this is interesting. And what kind of support you're thinking in Rholang in JavaScript? How this will work? Can you say more?
The way I see it is that when a transaction issues some Rholang to be deployed, of course, the user has the pop-up just like right now, but we could validate the structure of Rholang, for example, to make sure that the deploy ID is not sent to any channel or some stuff like that. I'm not exactly sure, but if you are sure that deploy ID is not used, maybe it's safe.
I see. So you want to analyze this Rholang code that is deploying and say, I know I can check something, right? It's not just a string. I understand some structure that you are saying.
For example, I know that it's not a vault. It's not vault related in any way, or some rules like that.
Yeah. This is something that we will have with the behavioral types, but yeah, for now, yeah, exactly.
Yeah, but yeah, of course, but you still need a Rholang engine to process Rholang, and in DAPI you don't have any kind of interpret Rholang. You can just consider it as a string and send it to Arnode. And of course, when people install DAPI in their computers, they have not Arnode software installed.
Yeah, that would be great. Yeah, without any need to send something to external node, right? Yeah. I was not thinking in that direction, but yeah, this is also like a very good use. Yeah, makes sense. And yeah, maybe we cannot create like a very rich type system, right? Which can check everything, but we can check simpler contracts. We can definitely check and say, yeah, this is this looks like transfer, and it's using all of this stuff, and yeah, it's we can check some specific contracts. Yeah. I mean, one of the things that I'm exploring with this simple Rholang is how difficult this is. Like for today, you know, oh, I will just add additional arguments to send, and you know, this will be like a different structure, and this will be like super easy. But you know, when you when you go like a little deeper, then you know, becoming more complicated. So yeah.
You couldn't just cheat and put a map in there or something, huh?
Yeah. I mean, the next step is to try to add continuations. That's the, you know.
Yeah.
I'm thinking about that, how to extract only the com event and this operation on the map, right? So we can say, oh, this is our operation on tuple space, and this is separated from this structural thing that Rholang is doing, right? When we are combining this in the map, because only when we are executing the Rholang, we are doing this this checking of channels. We are searching for the same channels, right? In all the other situations, we are just combining whatever we have in this map. And this is something that now we have Rholang always connected to storing this as a Melker tree with a history, right? So we can check the hash after the execution. But in many places, like Rafael mentioned, we don't need all of this other stuff. We just want to execute Rholang and say, oh, I have these channels, I'm executing this Rholang, and here is the state after the execution, or you know, or we are sending some result of some channel, right? But this is not important. We are just having some state after the execution, and for that purpose, we don't need the Merkle tree, the hashes, or all the other stuff. We are not care about that. So we are just executing Rholang. So it would be nice that we can extract only this part, and you know, because execution is much faster in this way. And this is what I'm exploring with Rholang UI or Rho UI. If we think about Rholang that can replace virtual DOM, then basically operation our execution of the Rholang can change the UI. And this is something that I would like to explore. How this model that I showed you is can be moved into direction of Rholang. So we don't operate on the functions, but we just write continuations with processes more in this way. Because this is like more natural. Our complete UI is, everything is in parallel, right? So with Rholang, this is exactly what we are doing. We have this synchronization. So, you know, we just need a little more to connect Rholang to virtual DOM, and that's it. We will have Rholang as the framework for UI, which I think maybe it's useful for a JavaScript developer to you know to be introduced to Rholang.
Yeah, I mean, I think most of our transactions will be off chain. So I'm very much behind a Rholang that runs in the browser, or I was actually hoping that we get one on in Rust eventually.
Yeah.
Assembly.
Oh yeah, this is also a good way of thinking. Yeah, to develop not directly in the JavaScript, but for example in Rust and compile in the same way from Scala, and yeah.
All right.
Cool.
I guess
I've got one more question about repl.it. one thing about when you're editing JavaScript on Glitch, it's live. I mean, if the program compiles, everything looks good. If you break, the syntax or introduce a syntax error, you get feedback. I don't see that on repl.it. Is that
Yeah.
not work there?
Yeah, they are communicating with the server, so they are executing the code only when you hit the run.
Okay, so all of my changes I've got to test with run, and then I get the errors if they happen.
Yeah, I mean maybe some language has some browser support for this kind of stuff. So maybe this will work for JavaScript. But for example, for Scala or C# or you will not see errors immediately. You need to,
okay.
Yeah,
I guess
it depends.
I got used to that. I mean, I really like that because it helps me fix syntax errors or keep from introducing them. And Glitch broke my Twitter bot. And so I imported it to repl.it, and it ran right out of the box. I was only having trouble with the editor. I couldn't get it to copy and paste, but I suspect that's because I'm trying to work in the secret .env file, and they've got some restrictions on it. But I was encouraged to see what you've done with it, because that gives me more confidence to spend some time over there, because Glitch broke it, but they stopped letting me ping my application to wake it up. They don't let your application run 24/7 over there. They go to sleep. And if you want them to do, you got to hit them from the outside. But they turned that feature off. Now you've got to go pro account to get that. But I don't, that's the only thing I ever used Glitch for. So I'm going to try to get it running on repl.it. And but it's very interesting thinking about getting Rholang running on repl.it as well.
Yeah, with different sites of that kind, there are like different way of how they are implementing this. On one hand, if you have everything in the browser, that is this is much more responsive, and because with repl.it, it's you need to wait with different languages. You are waiting a different amount of time, right?
Right.
So I was testing this because I was thinking, if we are going to develop this in TypeScript or Scala.js, or how this will work on repl.it, for example. And in Node.js this is much faster. Or JavaScript and with C# it's much slower. F# it's even more slower. And so different languages are behaving differently. Yeah, and this is also something that how this will work with Rholang. This is also something that it would be nice that is working very fast. I mean, the logic that I implemented in extension for Visual Studio Code. I mean, I was thinking how to do this in browser also, right? Because it's basically the same thing. We are communicating with the node with gRPC, and this can be in the browser or in the Visual Studio Code. It doesn't matter, right?
Cool.
Yeah, it may be time for you to move to Visual Studio Code, Gary. Now that the Windows System for Linux version 2 is out there.
Sorry.
Yeah, so I think Rholang will run on that. I'm pretty sure, right? I mean, we haven't. I haven't tried to run it on since I have version 2 up, but it should work, right? So full Linux.
Yeah, exactly.
Cool.
I mean, if you want to run JavaScript, this is also something that it's, you know, it's very good. It's supported very well in Visual Studio Code.
Yeah.
For example, if you open a project, I mean, for example, the client.js, what I was showing you. Let me just screen share very quickly. When you run npm install, you will get all of the dependencies, and usually you can create some script inside package.json, which is a description of your application. You can create some script that is running your program, and usually, sorry, in the development, this you will probably use some development library, and this library will watching your files, and whenever you click save, it will reload the program and show you what is where is the error. So you can have this experience of immediate response. What is wrong? Very much in your Visual Studio Code.
Yes, that's what I was thinking. You know, even with Rholang, the response from code is fairly immediate.
Yeah. Now with the gRPC, yeah. Previously with using CLI, that was you know
You still have the problem though with the deploy ID.
Sorry, what do you mean by deploy?
Well,
Deploy. Oh, you cannot use stuff for from blockchain to in the eval. Yeah. Mm-hmm.
Yeah, that's a bummer.
Yeah, unfortunately, I'm not sure that we will do anything about that very soon.
Well, what would it? I mean,
I will stop recording, right?
if we were to